We are, trying to make it as relevant as possible to what you're doing. I've had to learn some Python since we pivoted away from Ruby a couple years ago. So you might be tempted to make fun of my Python, but that's okay. So we're all learning something. So what I'd like to do, we have about 6 hours total with today and then I believe next Tuesday. So you guys will have a project coming up, and one of the innovations we're going to attempt this go around is to in session 2 kind of have you guys run a project as if you were doing your end of cohort project. Divide you into teams of 3 to 5 people. I'll let Tom figure out who that will be when the time comes. But then have you use Git. So toward the end of this session, we'll start to look at a silly little Python web app repo that you can make changes to, as a project team, and just put into practice some of the things that you're learning, in this session here. So for this session, I think first we'll kind of do some setup work, and get ready, and then take a little break, and then we'll get into some actual concepts of Git for the second hour, and then another break, and then the last home stretch we'll start to ease into how you would go about using Git to collaborate on your project together. So you may have interacted with github.com a little bit already. This is not github.com. This is just Git. We'll use github.com as a rendezvous point, as you'll see, but that's about it. We're not going to use the social coding specific aspects that characterize github.com. Forking repos, pull requests, reviews, things like that. So those are all good, but they're all just, we can only cover so much at a time. And what we're learning today is what underlies all those other fancy workflow tools and aids. So if you understand what we're looking at today, you'll know what a GitHub fork or GitHub pull request is doing, or all those higher level operations will make a lot more sense. At least that's the hope. So I guess a little bit about me real quick. Yeah, I'm with DRW. I think you're going to hear from more DRW today later on. Is that right, Tom? Is it the presentation day?
Yep, at 3 p.m.
Okay, yeah. So you'll see DRW HR. I think is going to do most of that, but you'll see a couple of people from my team in there. Kent Cowgill, and then Jordan West, who you may know from his time online TAing and stuff. He's recently out of Code Platoon and been doing a great job with us. Did an internship in the early part of the year, and then went full time just as COVID hit, and so he's been experiencing remote with all the rest of us for the last 7, 8 months. Yeah, I've been running that team for about, gosh, did you say 13 years, Tom? Pretty much, yeah, close to that. Stayed in the same place. I don't, I like what I'm doing, so I've been doing that for a while. Git is it's a simple data model surrounded by a complex cloud of thousands of complicated tools. So there's lots of stuff I don't know about it, but there's also lots of good documentation out there, and I'll try to point you to some of that as we go along as well. So let me share my screen if I can figure out how to do that again, and try to get to a place where, okay, what are you seeing now? Are you seeing repos?
Yep.
Or are you seeing github.io?
We're seeing, yeah, the github.io as well as your terminal on the left-hand side.
Oh, good. Okay, it's working. Awesome. So you may or may not have gotten a chance to take a look at the, at this page. Let me go back up to the top here. So there are some pre-work and references in there. I won't take the time to go over it because we're kind of, we've got a lot to cover. But if you have any questions for me, feel free to chat me or Slack me, and I can make sure I stop and cover your questions. We have from the last class, this is the syllabus we covered from the previous edition of this class. We're going to change it a little bit because we're going to try to work in this project simulation. And so we'll skim more lightly over some of it than we would have otherwise. But I do want to get into these two concepts, the 3 objects and 3 trees. So we'll be talking about that in the second hour. You may have noticed there's a student handout link at the bottom, so I'm going to be working from that. But I should probably mention just briefly, actually let's go into that student handout right now. So this is what we're going to be cloning down. This whole presentation that you see here under github.io actually is the same repo, but on a different branch. So I won't cover that, but if you're interested in something like that, Git has a little sort of simple way for you to put up a website by just checking in code and arranging it so that this tool called Jekyll can build it and publish it for you. So, of course, very limited design flexibility there, but if that's all you need, then this is a tool that could come in handy that github.com provides. But so let's jump right in then. Does everyone have a MacBook or a Mac? Can we assume that, or is there going to be other operating systems in play as well?
I think several students might have Windows machines.
Okay. Okay. So we should be able to work with that. I don't think I've got anything. Well, some of this is Mac specific by virtue of the aliases that I'm going to define. Are you using was it like Cygwin or something on the Windows machine, like a Unix variant?
Who's using a Windows machine? Is anybody?
Okay, so
that's good.
I'm going to proceed as if we have some variant of Unix on our inner environment, and if we need to set something else up, we can look into that. But that's what we'll go with for now. So okay, so here we are cloning the repo. So I have, by the way, if you do have a Mac, then Command K is handy for just clearing your screen of clutter that may have accumulated. So I'm in my home directory under src/cp, and it's empty, and I'm going to pull in this repo that we're going to be working with.
Chris, are you able to zoom in a little bit on your terminal?
Just expand this terminal here? Yeah, let me do that.
If it's possible. Is that better, everyone? All right, cool.
Good. Sorry about that. I keep forgetting that. Okay, so get things in order here that I can see everything. Okay, so here we are. Didn't make exactly that. I like to not type much, so I shortened that to CP instead of Platoon. And I'm in that directory, and then you can follow along with me here. You will. This should work. Okay, you should see something like what I've just done here. So it will have cloned, it will have created a directory with the same name as your repo as it sits on github.com. And so then we can cd into that directory. I'm hitting tab here to autocomplete. Existing files and directories will let you do that. And so here we have stuff. So next step is a little bit of kind of magic you don't need to know about for the long term, but it does help us to look at our Git repo and the elements of it. And this is this unpacking that we're talking about up here. So the reason for that is if we look under .git, which is where basically all of your repo is, your history, your branches, everything that constitutes your repo. There's an objects directory, .git/objects, and normally that has a lot more in it. And it does have a lot of objects in it, but they're packed up in a way that's not visible to us. So I've written a little small script that does the unpacking for us. So you can literally just type ./unpackobjects.sh, and it pulls it from that optimized place that it has them. And if you do an ls again, I just did an up arrow a couple times here. Now you see the kind of standard Git database layout that it works with, and we'll understand more about that in a minute. So yeah, it was originally in this was .git. Where am I at? .git/.git. There it is. So the database was originally here compressed into this pack directory, but now we pulled it out, and now it's up where it would normally be, up here under .git/objects. Okay. So our next step is going to be to, everybody okay up to this point? Good, okay. Next step is going to be to set up your shell to have these shortcuts for Git commands that you use a whole lot. So the way that we're going to do that is to use this file, which is just a shell script, basically. And we'll look at it first with cat, see what's in there. And these are just basically alias shell commands. Alias is a command in your shell. So here's all my aliases that are already defined. If I just type alias, you see a bunch of stuff there already. So what we're going to do is just run it, which you can do by, I'm going to hit clear again. You can just ./git aliases. Actually, you can't quite do that because it's not executable. So bash ./git aliases. So I have just ./git aliases. That's probably not going to work because I don't have the execute permission set on that file. But if you run bash and then pass it this file name, it should run what needs to run. So now if you have done that and that has worked for you, you should be able to see aliases for things that are relevant to Git. For instance, alias, if you say, let's see, we're in a repo, so this should work. So normally you could say git status, see stuff about your repo. If your aliases are in place, you can just say GS, and that's the same thing. You can verify that by looking at the GS alias and say, yep, that's indeed what this GS alias equals, if you will. Other things like, Git branch is handy to have to know about. So you can also say GB. So Git branch, Git status, it's done already. Git diff is handy, which is alias to GD, and returns nothing because there's no differences right now in a repo from what is already committed. Okay. Also this one we'll use a lot. ADOG. So if you type ADOG, you should see something like what's on my screen now. This is a tree history of your repo. So you're seeing the latest commit up here. You're seeing previous commits in a line down from this latest commit, and then you're seeing as I hit enter, kind of scrolls up. Arrows also work to go up and down in this view, or they should. Let me know if they don't. So you're seeing kind of what's happened in your Git repo and what is happening. We'll go over this more as we go along here, but you can see that here's where we're at. This is the head of our repo. We're on the master branch. It's this sort of symbolic representation. So our head commit is at the end of the end of master, I guess you could say. You can also see that the pointers from our remote called origin. Whoops, that's not right. What did I just do? The pointers from our remote are also there on the same commit. So everything that you see here is sitting at commit FC223DF. Our master branch is there, our head is pointing, so we're on the master branch by the virtue of head being pointing to it like this. We're also right up in sync with our repo that we pulled from, or cloned from.
Pardon me, Chris. I could not get ADOG to work.
Okay. What happens if say
the
alias
.git aliases worked and the append aliases worked, but ADOG does not work.
Okay, do any of them work? Does GS work? If you type GS, let me clear the screen.
GS does not work. I'm getting a bash : ADOG : command not found, and then bash : GS : command not found.
Okay, so it looks like your alias script did not take. Were you able to run this command here?
I did run that command and it didn't return an error, so I assumed it worked.
Interesting. Okay.
I have the same problem as well.
Okay, so it ran, but it didn't do the necessaries. And is this on a Mac?
Yes, I am on a Mac.
Okay, let's try just as a test. Try copy pasting. Say just this last line here. Just copy that and paste that like so, and then see if GS works after that. So just type or paste that in.
GS did work after that.
Okay, so try copy pasting the whole thing then.
Is there somewhere I can copy and paste that?
Well, yeah, you can. So you can cat the file and then just select it. That's all I did, is just selected the output that because concatenate just lists what's in the file. So I did this cat space get aliases.sh. Does that work for you?
Yes, that did work. I will try and copy and paste the whole thing.
Starting with the first alias all the way down to the last line with the alias in it. You should be able to just, Command C, Command V, and then it should all just run.
All right, I think it all ran.
Okay, let's try ADOG again.
ADOG worked. Thank you.
Yeah, all right. It's very important that it works. So good. Anybody else? Is that working for everybody else? Awesome. Okay, so here we go. So ADOG is the history down arrow. If it's if it's your environment is like mine, then down arrow and up arrow will work. Space will go like a page at a time down, and then you can use B for back to go a page at a time up, or just down arrow and up arrow. Enter also goes down. So, and then when you're done, you could just hit Q for quit, and that gets you out. Or just Control D, I believe does this. No, Control D doesn't do it. Just Q for quit to get out of that display. And that's all kind of a function of what's called a pager, which the output goes into this tool. I believe it's less is the pager that's being used to manage the paging of this output. But you should just be able to use up arrow, down arrow, B for back, and then space and return to navigate around. Okay. So we should have our aliases. Let's do one more step, because it's in our present shell, but if we get out of the shell and go back in, it won't be there anymore. So I would recommend that we go ahead and put it into a place on our system where it will come back for us next time as well. And that is what this guy here is about. So hopefully you can just copy paste that line. I'm going to clear my screen and paste this line here. Let's see what happens. Okay, so it should have just worked, and if it did, I'll cat it out to see what's in there. So all it basically does is run some shell code to put your get aliases.sh lines into your shell's profile. So for instance, if your shell is, I think mine is ESH. Oh, it's bash, never mind. Then it's going to take this get aliases.sh content and put it into the end of my bash profile. So there's some substitution going on here, and the file name ends up being tilde, which is another name for your home directory in Linux. And when I say Linux, I also mean Mac OS. And then it substitutes bash, and you get tilde/.bash profile. So if I look at the end of my .bash profile, which I can do with tail, with a Unix command, then I see nothing. Okay. Because I misspelled it. Yeah, so if I tail bash profile, I don't see what I expect to see. Which is interesting. Hold on, I'm just going to, I won't do this for most of the class, but I'm going to jump into VI for a minute. Just because I'm familiar with VI as an editor. Okay, so maybe it's because it's already in there. I'll not dig into that too much, but you should see it if you do a tail on your bash profile. You should see those aliases at the end of your bash profile if that worked. So
I saw that, Chris. I think it did.
is that good for you? Okay, awesome. If it didn't work, let's you know, during a break, hit me up and we can figure out what's going on there. But worst case, you can always just do, you know, run the copy paste the commands into your shell again, and you're on your way. So that brings us down to, okay, basic Linux shell. I'm going to skip that for now. I'll try to explain what I'm doing as I'm going along, because I'm assuming that not everyone is familiar with Linux and the shell at the command line level. If you are, then just somebody just chat me and say we've got all this. But that's kind of been where previous cohorts have been. So we'll go with that plan. Okay. Half past the hour. So with the next, say, 20 minutes, I want to go through the actual Git database and become familiar with what's in there. And that begins to ease us into this notion of these three objects and three trees. So content addressable file system. So you notice let's clear the screen again here, do an ADOG. So you notice these goofy looking kind of hex-like numbers and letters here. Those are the addresses in this content addressable file system. So what do I mean by that? Let's go down to where we are at head here. So let's dig into what's being said by this line here. So if we look at what head is, we can look on here and see it. You know, we can see, oh, head is at master, which is actually at this commit address here. We can also do it by using this command called rev parse. So we can get rev for revision, rev parse head, and we see all this, plus we see a whole bunch more. So this actually is an abbreviation for the full address of this commit that we are sitting at right now. And we can actually go down and see it in the database. Recall that Git objects. So we can say, let's look for .git/objects fc. So there is an fc, but it's just a directory. And then the rest of the commit, SHA, here I'll explain what SHA is. The rest of it is a file name in this directory. So that is actually where this commit lives, is in that file in a very compressed format. So you can't actually just go to that file and list it out and see anything that makes sense without doing some serious transformation on it. But it is there. And the point of content addressable is that's only where it's at. So in other words, anything that has this address of, you know, FC223DF66 blah 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 is right there. And if you were somehow to make another commit with that same, you know, that came up with that same address, then that's where it would be. There would be only one is necessary, because if you apply the algorithm, actually let me back up. So there's the address. So let's back up to the content part of it. So the content part means that the way you come up with this address is by hashing the content, by applying an algorithm to the content that comes up with this unique address. And that's where the word you might have heard the word SHA thrown around. Here's a SHA. SHA is short for Secure Hash Algorithm. And so that's the tool that generates these hashes. And so how is that useful? One way that it's useful is that you can be sure that if you have some content and you run it through this algorithm and you get this number, that content is the same as whatever, whatever other, how do I put this? That content is unique. So if we want to get the address, if we want to reference that content, all we need is that address, and then we know exactly what we're getting. Now we can't take that address and expand it into some whole commit with all of its all of its code and everything. It's a one-way address. But it's like going to the post office and saying, okay, here's my mailbox number, give me my mail. And they know exactly where to go to get it. They don't know what's in it necessarily, but they know where to go to get it. And that's what this address does for us in Git's database. It tells us exactly where to go to get what we need. So what we need is actually in the file that this is the mailbox here under Git objects fc blah blah blah. That is our mailbox, and that's what we need to open in order to get the content that we care about. If that makes sense.
I have a quick question on that, Chris.
Sure.
Yeah, so you're saying, so this is a unique string of characters that ties specifically to a commit object in Git, basically?
Yes. Yes,
Okay.
it's used to generate the file name under which the content is stored.
Got it.
So the content, so you run the content through the hashing algorithm, come up with this number, and then use that number to store that content with this file name. This is just a file name, so we can, it is a file on the file system with permissions and ownerships, and it's just a file. So we can what's in the file will tell us where, like how our database is organized, and we'll go into that a little bit as well. But anytime you see a number like this, that is a SHA. It's short for Secure Hash Algorithm. So there are several. So Git uses this for several types of objects, and I'll show you what I mean by that. So you can go through here. You can actually use sort of low-level Git commands like hash object to generate these things from content. So I'm not going to go through that right now. We could, I think, understand how to use them without.
Could you make the text on that one a little bit bigger as well,
Oh, yes,
please?
Absolutely, absolutely.
Thank you.
Sure, thank you. So this is just an exercise in taking some content, putting it in a file, and then running the hash on it, basically. And then you come up with this SHA. Now it doesn't put it anywhere unless you use this option -W. Then it actually takes that content and puts it in the database, like if you had actually done a commit. So then you can see it. You can see it in the objects directory, if you like. So I'll leave that as an exercise for the reader if you want to go ahead and try that. Otherwise, you can just take my word for it for now, and we'll soldier on. So let's use a normal Git command and try that. So you should be able to do this. This is just normal Git, but as we do this, let's look at the Git database and see what happens while we do it. So we can make a file called, we can use cat actually. Actually, let's use echo. So we're going to echo something. So a couple words, and we're going to redirect it into a file called hi.txt. Okay. So here's what we're doing, something like this. And if we look at hi.txt with cat, that's what's in there. This is the content, right? So nothing has happened in the Git repo just so far. Nothing in the Git database. We can see that the file's there. We can look at status, and we see that it's Git also sees that it's there, but not tracked. There's no record of it in the database yet. Then we can do a git add, or if you've got the aliases, you can just do GA. Okay, now if we do a git status, now it's turned to green because now we've got it in this staging area, which you may have been acquainted with a little bit. So let's see, is it in a place where we can see it? There's the staging area is a place where we can see it, but I'm not gonna use commands to look at the SHAs right now. I'm just gonna go ahead and commit this with git commit, and see what we see. Okay, so now what do we got? We've got a commit to master. This is the SHA that actually got created for that commit. So how would we go into our .git objects directory and find this? Anybody want to take a swing at that? Where would it be?
Inside of the git /objects directory. I'm assuming like ls.
Yeah.
Hack l.git /objects.
Okay. And where from there?
B6.
So yeah, B6. Yeah, what Git does is it takes the first two characters and kind of lays out its commits in this kind of in this directory structure to shard. It shards its commits into these directories so that mainly because I think Git or the Linux file system has some limitations on how many files can be in a single directory. So if you had everything just in one directory, you would blow out the limits on your what Linux allows for directory structure as far as file count per directory. So this helps get around that by giving one more level. Okay, and then what should it be after that? B6. Just the rest of the SHA, right? After B6. So there it is. There's our file. And we can actually see when it got there if we do an ls-l. So this was created at 9:38, which is about a couple minutes ago. So that really does look like that's where our commit lives, right? So that's what's happening when you do a commit is it's putting your content into this database according to the SHA that corresponds to that content. Now we're going to dig into that because there's a little more to it than that. What is it? So let's take 10 minutes then and try to see how far we get. So we've looked at head a little bit. Where is that defined, right? If we do a git rev parse head, that's where we're at now. We just made that commit. this is our latest commit. If we do adog, now we're up here, right? Because this is the latest commit. We've put it on top of origin master where we were before, and so you see kind of where it came from here, and then the next commit associated with master is up here, and so as you see this history going on of what has happened on master. And you also see this down here, but notice this is the star denotes where the commit actually lives, what branch or what line the commit is on that corresponds to this star. So this is a separate branch going on here. You may be able to pick that up. The graphics aren't great in Linux at the command line, but you know, this red line goes up with these stars up here, and then this is kind of a different line that comes on down, and the next commit, say after this guy, is down here where the next star is, if that makes sense. And you have to keep on going to find out where it branched off from this line that we're on right now. So this is the common ancestor of these two branches, you could say, that come on up here. And so when you're switching from branch to branch, you are, basically jumping to these pointers, these different pointers that live in your Git history. You can actually see that in, let's go back into that .git directory a little bit. So there's not just the objects directory, there's also some other stuff here, like head, for instance. You can see what kind of a file that is by using the file command. And it gives you sort of a hint as to whether or not you could possibly list it out on your screen or not. If you list a binary file, it probably is going to screw up your screen and you'll have to quit your terminal window and start it again. So this is handy to know whether or not you can do this. So because it's ASCII text, it says it's a pretty good chance we can just cat it and see what's in there. And it's indeed just text. And indeed it's not actually a SHA, but it's a reference to something that does point to a SHA. So when you see ADOG, this refs heads master kind of is represented like this on your ADOG output. So that's how Git knows to draw this on your Git history graph is by what's in head right here. So okay, so refs heads master, that kind of looks like a path, and there's a directory called refs. So I wonder if we could go down in there, and I can hit tab to autocomplete and see what's in there. Okay, so there's a heads directory, so let's look at that. And there's something in there. Is it a file or a directory? Let's use -L and see. So because this is a dash and not a D here, then we know it's a file, not a directory. And we can also see what kind of file it is. It's the same trick. Another Linux trick you could use is to, instead of typing this all out again, you could use just this $, which says, use the last argument of my last command, which is, of course, Git refs heads master. So again, it's ASCII text, so that means we can cat it. Let's just cat the same thing, use $, and sure enough, there's our commit SHA. So all that just to say that there's, this is the database. Here's where things are at in the database. As you create more branches, you'll see more things under Git refs heads if you care to look. Of course, you don't have to look. That's not necessary to use Git successfully. but it's interesting to see how it works. So let's, and by the way, those red references are also there. And so with the place that we cloned, or we cloned from, Git gives it a name. It calls it origin. And so when you see origin here, it's just kind of it's a tag that Git uses to say, this is the name of that remote place where you've got this repo from and where you may want to push back to. So you'll use that when you do git push, as in git push origin master, for instance.
I have another quick question, Chris.
Mhm.
So when we created the file called hi.txt and we looked at it in our object directory, and then we did a commit on that, and then we ran adog, that hash doesn't come up in the log for me when I ran adog. Is it supposed to be in there?
If you did the commit, it should be in there. Yeah. Maybe you can share your screen when we take a break. I can see what happened.
Okay.
That does make me curious. So that's okay. That kind of is a quick look at where the Git database is, and a very brief overview of kind of what's in there, how Git stores its objects, and how they're generated, with the SHA algorithm. So now we're going to, I think, take a break, and the next tranche of work will be to look at what kind of objects you can store with the SHA algorithm, and that will be, these three kinds here. So there's a very specific layout to those objects and how they're used, and so we'll be able to dig in and see exactly what's in these objects and how they're stitched together to produce a repo and commits and the content that you care about when you're collaborating with Git. So let's take a break and come back at just right around 10 o'clock Central, and go from there. And James, I'll stop sharing if you want to share your screen and look at what you're seeing.
Okay. Okay. Can you see?
Yeah.
Okay.
All right. So
8B is where the 8B is where it went. And actually, I think I may have been misreading it. It's F6, F22. So.
okay. So you did your commit, and your commit is 03DB1A8 at the top.
At the top right here. Okay.
So try doing it. Your command line, do git show. Okay. So there's your content. There's what was added. Dev null means that there was no file there before, and now there is. And, the A side was nothing, and the B side is hi.txt. And the content that was added was the cool Git line.
Okay.
Now that's a good point. That your numbers, your SHA is different than my SHA, and that's very significant as to why that might be. So we'll go into that. So it looks like your commit did work, but it has a different SHA than mine did.
Okay, so it's the top here. That's my comment, my commit comment there.
Right.
And then
you put it on top of the FC223DF commit.
Okay. And then to find this in the object directory, like you were saying, we would Git objects, and then it would be the prefix, so 03 we'd be looking for here.
Mm-hmm.
03. And 03. Well, I guess I think I'm missing something here.
So 03, and then there's a couple different commits that looks like they start with 03, or a couple different SHAs.
Oh, okay,
We
okay.
don't know if they're commits yet because we haven't looked at them, but yours does look like it's there, right?
This one here,
Mm-hmm. So
and it's supposed to match one of the, or not, it's not supposed to match one of these.
well, it does if you concatenate 03 with the rest of this, the DB1A8.
Oh,
So your actual SHA.
I see. Oh, the first three, that's the prefix. Okay.
First two, yeah, is the direct. It's turned into a directory, and then
That makes sense.
the rest of it's used to create the file name that contains the
I
compressed.
see. That makes sense why I wasn't seeing it. Okay, great.
So you're
Great,
so you're
okay.
good. You're all good.
Good. Okay, thank you.
Yeah. Anybody else have any questions? Otherwise, we'll pick it back up in 5 or 6 minutes.
Yeah, hey Chris, I have a question actually. It might be like a super naive question, I'm not sure, but I know that we keep referring to Git in itself like as a database, but it doesn't really have any similarities with like a SQL database. Like I shouldn't think of it in terms like that. So every single time we go and we basically have that .git that lives like at the root of that project and is like unique to that project. So it's not something that's like globally ever on my machine or anything. It's always just in that project by itself.
Correct. Yeah, that is the database for your repo. And a SQL database is a relational database. It's a different kind of database. So yeah, when I say database, I'm speaking in a more general sense than a SQL database or Oracle or SQLite, or even those. There's time series databases, and so this one is just local. It's the kind of database that is replicated 100% when you do a clone, and pieces of it get communicated over when you do a push, not the whole thing for performance reasons. But yeah, you've got all your history, and this is important, kind of in context of other version control systems of the past, like Subversion, which doesn't bring over the whole database. Like if you're on Subversion and you want to see history, you only get a very little bit that's been cached locally. The rest of it is going to be on the server. So you can't like go on an airplane and work on your Subversion project and expect to really see much as far as history goes, or do much as far as committing either. You have to have the server online in order to commit a Subversion repository. So
Got it. Okay, I appreciate it. No, that clarifies things for me. I appreciate it.
sure, yeah, that's why they call Git a distributed version control system. One of several, but compared to Subversion, it's that you get a lot of advantages for that with that. Cool. I'll be back in a minute. Okay. Let's see. All right, we ready to do some more? No news is good news. All right. So James made a great point. You know, his mileage varied. He made a commit, and it wasn't the B658426 commit that mine was. So let's talk about why that might be. Anybody have any guesses? Any thoughts? Why did he have a different commit SHA than I did?
The content was different.
Exactly. The content was different. So let's look at what that content actually was. You know, if we do git show shows us the diffs in our last commit versus its parent. So for instance, git show tells us, okay, well, it tells us a lot, doesn't it? It tells us the commit itself, where it's at, author, date, the comment for the commit, and then it gives us this diff, A side and B side. So, so it's a new file. Here is the permissions for it, which is a kind of a Linux, you know, Unix sort of construct. I won't get into that at this moment. And you kind of see this tells us that the file wasn't there before, basically. Like it used to be nothing. That's a Linuxism for nothing. Dev null is a device on your system that just accepts input and output and throws it away. Now it became a real file called hi.txt. And then here is the difference in the content between nothing and your new file. So, so how does all this, like, how does Git know all this, right? Well, there's a command you can use, if I can remember it. You can use git cat-file and then P for print and give it the SHA or some piece of it. You can give it any subset of this whole thing. As long as you give it at least enough to be unique, so it can tell it from other SHAs that may be down in the database, then it should do what you want. So what this does, this is cool. We've been talking about content, and you know, we think of our content as what's in our file. You know, that's to us, that's our content. But when Git hashes content, what it hashes is everything that has to do with that particular type of thing that it wants to store. In this case, what it wants to store is a commit. So that's one of our three types of objects, the SHA objects. So commit to Git is all of this right here. So if any of this, in other words, if any of this changes, the commit SHA is going to be different. You know, that actual number letter designation will be different. So what are the components? So there's the tree, and then there's, you know, a SHA for it. So that's our second type of object that Git cares about. It's a tree. So it hashes trees as well and comes up with handles for those. There's a parent, which is another commit. That's a commit SHA. With that, and that's how Git draws the graph. Is it looks at the parent SHA, and then it just connects the lines, connects the dots literally. Then there's the author, which, that's verbatim what it puts in. Git also distinguishes between author and committer. So that goes in there as well. And then there's a blank line, and then there's the comment that we add to describe the commit. So that all is the content of a commit SHA. Those are the, those are the attributes that get stored. So it takes this whole thing, runs it through a hash, and then it comes up with whatever number it comes up with. And so that might explain too, or would explain why, like if I did another hi.txt file, I won't do this, but if I did, it might be natural to expect it to come up with the same commit SHA because it's the same content, right? But that's just the file content. The rest of the SHA content is all this stuff here. And if you notice, the file content is actually not in the commit. The file content is somewhere down in this tree. So Git has actually, done other stuff besides just create a commit SHA. It's also created a tree SHA. So let's see what is in that. Git cat-file-b. And let's grab some of this tree SHA. Okay. So what's here? So from here on down. So what does this look like? What does it appear like we're seeing in this content?
It seems like we're seeing all the files in that directory.
Exactly. Yeah, files in that directory, and also directories in that directory, right? So a tree is a tree. It's recursive, potentially, right? So we also eventually see our hi.txt here. We're still not seeing what's in there, but we're tracing our way down, basically tracing our way down the Git database schema, if you will, to see where our content for hi.txt actually lives. And this leads us to our third object, which is the blob. So how might we look at the blob content, do you think? Yeah. What is a blob?
It's a file.
It's okay. Well, it's content. It's the content of the file, and that's all it is, right? When we talk about our file content, what we're really talking about in the Git database schema is, the contents of a blob that is attached to a tree that's attached to a commit, if you will. So when we say git commit, or git add and git commit this file, all this stuff is getting built behind the scenes in order to place it in your Git repo database in a way that you can manipulate it, right, and push it and change it and all this. So again, the content of a commit SHA is going to be something like this. The content of a tree SHA, which is this thing here, E58162, is going to be this. So a tree SHA is going to have, file permissions for a blob, which lives here and has this file name. So the file names actually live in the tree, not the blob SHA. The blob SHA just has content with no file attached to it whatsoever, right? That's just what it is. You have to look at the tree to find out what the file name is and the file name permissions are, and where it is in the directory structure. Yeah. So those are our three types: the commit SHA, the tree SHA, and the blob SHA. And if you kind of look at it in this kind of diagram. So this is obviously isn't ours. This is just something I pulled from Git SCM. This graph, but that kind of represents what's going on. And you get SHA, you get hashes for each of those kinds of objects as you add to your project and commit it to your Git repo. And so it uses all that to draw these, when we see the graph, the ADOG graph, it's just following those different object types and pulling out what their attributes are and stitching them together into a graph that makes sense to us. But all that information is organized in this way. And so that's what I mean when I say that Git is a simple data model with a hugely complex set of tools that do really, really cool stuff. But at the bottom, this is what it is. And if you want to find your way around Git with those tools, knowing how it's put together like this is essential to not getting lost in the matrix, if you will. So, okay. 3 kinds of objects. So we've talked about Git add and Git commit and used it a little bit, but what's really going on here? So what we're going to shift to now is kind of another axis, and we're going to look at how these 3 objects are used to move the state of your work around in a context of a Git repo. So we've seen on your, get this in the same page here. So we've seen head and how it looks, right, and how it's the latest commit. We've also seen that it points to a branch, which will, as we saw here, moves along as we make more commits. So your head comes along and your branch comes along, and it grows in a history. And then we've also got this notion of an index. So let's do a git status to see where we're at. Okay, there's nothing pending, right? We're ahead of origin master, but there's nothing going on in our repo. It says our working tree is clean. So what is meant by clean? Let's make it dirty. How would we make our working tree dirty? Anybody got any ideas?
Just change a file.
Let's change a file. So I just changed hi.txt. Okay, you can use your chosen editor, of course, to do so, but that's what it is. If I do git status gs, now what do I see? Saw what I saw before. That was there previously with git status, but now I see some other stuff. Changes not staged. And it tells us what we can do here. We can either, do a git add, or we can do git checkout, which in this case doesn't make sense because, well, actually it does make sense. Never mind. If we don't like those changes, we can do a git checkout -- and then the file name, and then it throws away those changes. But let's dig into what actually is going on when we do something like that. So let's try that. Let's try what it recommends here, right? We'll do a git add. And then another git status. Okay, so what's different now? What has happened? Did our file change some more?
It staged the file to commit to your Git repo or your Git thing.
Yeah. Yeah, the file itself didn't change. It still says what it said, right? I mean, we made the change, and the change is what it was. But the state of the file, as far as where it's headed, has changed. And that's where we get into these the trees. Okay. So if you think of your workspace, that is, in a sense, in a very real sense, a tree, right? It's a directory tree. So that's what you interact with. That's where you make your changes. That's where you build your code. That's kind of your working area. And so Git doesn't necessarily know what's going on there until you tell it. If it has a file or directory, actually a file that it already has knowledge of, then it does know. But if it's a new file, then there's no SHA of any kind that represents that file in the repo database. So when you add it, then it kind of moves into Git space, and that's the staging area is called the index. So that's your second tree, and so it's a representation of your workspace, getting ready to go into Git, basically. So when we do a git add, that's what we're basically moving or copying, really, that hi.txt change into the staging area. And so there are git commands you can use to look at the index and look at what SHAs are there, but that's, it's not really necessary to dig into that. But it's basically a place where Git creates the objects that are going to later be committed. And where we attach the rest of that stuff to it, like the author and the comment and the parent and things like that. So that's that's not all there yet, but it's getting there. And then finally, the third tree is the actual tree that's represented by the commit. That is the head commit that we're on. So as we did before, a few minutes ago, we started with head, and then we saw the commit content, and then we traced our way down to trees, and then finally to blobs. That's a commit tree. That's fully represented in Git. You could blow away your repo, clone it down again, grab that same SHA, that same commit SHA, and then you could reproduce that entire thing out into your workspace. So as we see, changes start in your workspace, they flow to the index, and they flow on into a commit that is tacked on to the previous commit. So, but that flow doesn't always go that way, right? Sometimes you decide you don't want to commit something, but it's already committed. So understanding these trees helps you to move your work around or add to it or modify it in ways that are efficient without having to kind of start all over from scratch. So let's try that. Let's say we've got our hi.txt, and you can go ahead and follow along if you want to make a change to your own file or any file. Make a change to it, do a git add to it. And again, we're sort of propagating state from the workspace into the index by doing a git add. We're making the index like the workspace. And then when we do a commit, we're going to make the head like the index. So it'll just march on into the repo. So there it is. There it's sitting in the index. So now I can do a git commit. something like that, right? So do a git commit. Okay, got yet another commit SHA. If I do a git status now. Okay, now I'm ahead by 2 commits because I've created the file with the previous commit. What if we change our mind? So this is kind of where, like, when I was first doing Git, because all the developers in my company were pushing us to do Git, and I was a little grumpy about it. I would see things like this, and they would ask me, okay, how do I revert a commit? And I'm like, I don't know. It's Git. It's not Subversion. I don't know. So I finally got tired enough of saying that to go learn Git and really start to appreciate it. And this is one of the points where you can really start to appreciate it. But you have to know how these trees work in order to, or what's going on with the trees when you're doing Git commands to get there. So for instance, say I want to revert this commit, right? This commit I just did. Maybe I don't like the comment. Maybe I don't like what the content that I committed. So any ideas how I would do that? Has anybody run into that situation already? You've always been happy with all of your commits. Okay, cool. I'm not happy.
You maybe
with
somehow pull an older commit out of your record.
Okay. Well, yeah, you want to back up, right? So maybe I've got. Well, let's do this first. So let's back up. So there's this command called Git Reset, and it has these 3 modes that have to do with what you're doing to your different trees. So the default mode basically backs up to 2 out of the 3 trees. So if I say Git Reset, and I have to give it something I'm resetting to. So when I say Git Reset, it says what do you want to reset to? Now if I say head, well, nothing happens because I'm already on head. I've just reset to where I already am. Right? So I have to give it something different in order for something to happen. At least in the situation I'm in right now. So what I can do is I can use some syntax. Let's do it the hard way first. The hard way, but obvious way. So clear my screen. So here's where I am now, right? At the top, I want to go 1 back, which is here. So one way I could do it is I could copy that. So Command C. I'm going to do a Git Reset and then reset, and then just copy that, right? That previous commit. Okay. And that default behavior is to basically change 2 out of the 3 trees. So if I think of my head as being kind of the farthest out, I move the head back 1, and then I also move my index to where the head is, but I leave my workspace alone. So hi.txt is not changed in my workspace, but it's gone back 1 in those other 2 trees, if that makes sense. So what does that look when I do a git status? Okay. So if we remember, hi.txt is not changed in my workspace, but it has backed up in those other 2 trees. It's as if I had not yet done a git add, if that makes sense. So that's the default behavior of Git Reset, is to go 2 trees, but leave my workspace alone. So now I can, now I can change it again. I could also add more stuff to the commit if I wanted to, right? I could say, you know, let's have a by.text. Right, so now we've got, so one's modified, one's untracked. If I do a git add dot, that pushes everything from my workspace to the index that's capable of being added, right? So now there they are. And so now I'm going back forward again, basically. And let's go ahead and just commit that. So Git doesn't really know what I did when I, the previous commit. So I have to kind of remember or come up with a new comment. Okay. So there's those. And notice that that previous commit is gone. Which could be a little disturbing. What if I want to get it back? And this is another, I guess, a superpower of Git, is that it's not really gone. So let me talk about that a little bit. If we remember, I'm going to scroll up and see if I've still got enough history to do this. Yeah, it used to be this guy here, right? It's 5DDC490. Is that still in the database? 5D. Yeah, DC490. So sure enough, it's still there. Right? It's not gone. Git has not purged it. It won't purge it unless we do some pretty specific, intentional, pull out some of that constellation of Git commands and make it go away. It's not going to go away automatically. Now, if you push your repo and then you clone it back down again, then GitHub.com will go ahead and clean it up for you. Then, if there's these dangling commit SHAs that have nothing pointing to them, it'll clean those up. But you'd have to do something like that in order for it to be truly gone. Or you use a git prune. That's the kind of thing you would have to do to purge it 100% out of your repo. Otherwise, you could get it back by several means. You could attach a branch to it. I could make a branch called old stuff. And you may not have used arguments to branch, but you can. So you can attach a branch to any commit. Right. So I could do this. And now if I do an ADOG, oh, there it is. Now it's back. Right. You've got to figure out what that means to you. Do I want to merge it? Do I want to keep it? Is it just for my historical reference? That's entirely up to you. But you can get it back, or make it visible, I should say. It's still there. Another way you could get it back, if if you can't scroll up and you've gotten rid of your scroll history, there's a command called Getreflog, and that just shows you where your head pointed to previously. It's like a history of where you've moved head around to, and it tries to give you some information of what you did to move head, where you moved it. Right, so you could kind of troll back through your Getreflog, and this is only local to your repo on your machine. The reflog doesn't get pushed up when you do a git push. This is for your records and your eyes only, so to speak. Doesn't move around with the repo. But, you know, can certainly come in handy if you need to back out or figure out how to go somewhere that you've been before. So Getreflog. So where are we? We've pushed it. We've used the default reset, which moved back 2 trees. Let's try some non-default. And the non-default ones are soft and hard. So the default is what they call mixed. So that's moving 2 trees. Soft moves 1 tree. So let's try moving only 1 tree. Okay, and we want to back out again. So we say this syntax says 1 commit before head. We could say that, and it would mean 2 commits before head, but we only want to go 1. And let's see where we're at now. Git status. Okay. So what's different from when we did just the Git reset default as far as the status is concerned?
Is it because they're still actually staged to be committed and before they were just in our local workspace?
Yeah, exactly. It's green and not red, right? And that's what that color coding means. Is that the green stuff is in staging and the red stuff is only in your workspace as far as the changes go. So yeah, it just rolled it back just 1. And why would you want to do that instead of mixed or hard? Well, maybe you've got a whole bunch of changes you committed. Maybe there's 20, 50, 100 files, and you committed it, and then you said, "Oh, I forgot one," or you know, I did a little diff, and I saw one thing I wanted to change, and the rest is good. So sometimes it can take a while if you're in a big project to set up all these things you want to stage. If you're doing a big refactoring, you know, there could be a lot of work that is characterized by what's in staging. And so if you move it just, you know, from the commit just to the staging, then you don't have to do all that work again. You know, I can say, well, you know, I don't want to change this, but I do want to change this. And then you just change part of it, right? So you just something like that. Git status. So now you've only got to, you know, add this part and leave the rest, kind of leave the rest alone and go on in. So, you know, and do the same thing. Okay, so finally there's the Git Reset hard. And that is kind of the nuclear option. If you decide you don't like anything in your workspace and you want to make it all like it was before, you can just set it all back. And this is a great way to, you know, if you want to move your head around or move your branch around. Let me show this here. You know, suppose you want to just, for whatever reason, put master back on the old stuff, for instance. You know, you can do that with a Git Reset hard, or you can move it back to here and throw away the stuff that you did up here. Or maybe just leave it on a branch. Maybe you decide, you know what, it was a mistake to do this on master. I should have been thinking more. This should be on my own branch. So to jump ahead in the curriculum a little bit, let's do that. So recall I said you can do a branch on anything, right? So I can do a Git branch. Something like this, right? So I'm basically marking where I'm at with a branch. I'm not on the branch. I haven't checked out to it yet, right? If I do git branch, I'm still on master. But if I look at ADOG, there's also a branch here, right? And so if I move away, because there's a branch there, it'll still show up in my history and I can still go to it when I want to. So what I'm doing is I'm saying, you know what? I'm going to leave this on a branch. I'm going to change my mind and not do it on master. I'm going to move master back where it was, but leave this stuff on a branch to work with later. Or work with, you know, out, so I don't mess up master for somebody else just yet. Because maybe you want to put other stuff on master. You know, the stuff you've done here is not ready for master yet. So how would I move master back to here? Several ways, because all that Git Reset needs is an address. And so I could use this for the address. I could use this for the address. I could use this for the address. Any of those symbols that sit on that commit I could use, and Reset would know what I mean. So just for fun, let's use this one. Okay, and it tells where head is now. So head was up here. Now there's just that branch up there that I made, but we are actually back here at where we started at origin master. So we've effectively branched, but kind of like, you know, in an abnormal fashion, because we forgot to branch before, which happens to me way too much. But with Git, you can make it okay. But this is where knowing how the trees work comes in handy. You know, if I'd had to name a command, I probably wouldn't have named it reset, because that doesn't make much sense to me out of the box. but that's what it does. So reset, soft, mixed, which is the default, and hard are the ways that you move your reference between those trees. So, you know, here's maybe why they call it reset, is because it resets trees. So here's some more kind of documentation as to what's going on. And we've covered all that. So let's see. Okay, let me see if I can give you guys an exercise to do for a few minutes. And right here, if you can see this move a change forward through the trees. Try working your way through that for the next few minutes and seeing how that goes for you. Just to cement some of this in your brain a little bit. And if you have time, do number 2 as well. So it's 10:40 right now. So let me take any questions if there are any, and otherwise go ahead and feel free to take the next 20 minutes or so to do number 1 and number 2 here, and practice with that a little bit.
Is it all right if we do this in our current directory that we're in, if we would following along?
Yeah, absolutely. Yeah, and you can certainly use this repo, yes. Okay. How we all doing? Any questions, comments, corrections to the curriculum?
The first time I do the git diff, I guess each time I've done it without the staged tag on the end, like I haven't really been getting any output. Is that normal?
So yeah, so git, that's a very good question. So git diff is one of those commands that is sensitive to the state of your trees. So, you know, if you do a git, and of course git status is another one, but if you do a git status and don't see, and your tree is clean, and then you do a git diff, by default, the diff that you do is your workspace with respect to your index. So if there's no changes between those two trees, it'll be empty output. And there's also an option to diff called -- staged, and in fact, I use a GDS alias for that. You know, git diff -- stage, because I do that so often. And I'll use GD for workspace versus index, and then I'll use GDS for index versus what's committed, and just kind of see what's outstanding, and kind of keep my bearings, if you will. Yeah, very good question. So yeah, GD, GDS, very frequently used in my world. Great. Any other questions? Okay. So kind of on the home stretch for today for this class. I'll talk a couple minutes about Git and its career implications, and then begin to shift into looking at this this Python web app exercise, and start to use some Git commands to poke around at what makes up this thing. My team and I did a dress rehearsal on it Tuesday, just to see how it would work. So it was somewhat controlled chaos, but it was fun. Well, definitely a lot of actual project management issues came up with it. So you know, that tells me that it's I'm not sure how it's going to go, but I think it'll be useful. Because you'll certainly encounter that in not very many weeks from now. So, you know, as much as we can drive those issues out and deal with them now, you know, that'll be useful to do earlier rather than later. So hopefully we can accomplish something there. Okay, so Git. I mean, the stuff we've covered so far, you know, for most people, myself included, is not really all that interesting, because we're not doing anything with it yet, right? And past classes have tended to sort of check out right about this point. You know, I'm behind. It doesn't work on my machine. How is this relevant? And you know, I find out about this after the fact. And so I'll share a quote or paraphrase of a quote from one of my teammates who he's been a consultant in a lot of different kinds of companies, and over probably the last 10 to 12 years. And for him, wherever he's been, Git has been incredibly at the center of what he does. So, and right now there's no sort of Git killer coming up that I can see. Like there's other things that do similar things to Git, but you know, GitHub.com and Git are for the foreseeable future going to be real heavyweights in version control. So for us, it behooves us to really know it well. It's also true that people don't know it well. and struggle. So if you can, graduates have told me this, that if, they've gone into a place as a newly minted full stack developer, and the ones that have known Git have really tended to make a place for themselves quickly in some teams, because there are nuances that, unless you understand the underlying mechanism of Git, it's once you get off the fairway and into the weeds, then it's Google time, right? And that only gets you so far. So all that to say, hang in there. It's worth it, and it'll pay off. So while I'm giving unsolicited advice, I should mention that besides Git, the two tools, really the one tool I would know is Vim. I haven't harped on Vim yet so far, but learn Vim, or if you want to try an alternative, learn Emacs. The reason I say this is because Vim and Emacs, especially Vim, I think, are going to be on any system, any Linux system that you encounter. That's one. You don't have to install a big IDE. It's already going to be there. And on some systems, you can't install a big IDE. If you go on some server somewhere that you've got to troubleshoot, you're not going to have VS Code on that server. So you're going to have to edit configuration. So you want to be familiar with a tool that lets you do that efficiently. So Vim is one of those. Emacs is another. Not too many others, fall in that category. Vim is also programmable. It's also, it's been around since late 70s, and has managed to still stay small and light and incredibly feature rich as well. So the other thing, I would suggest learning Bash. I think you're going to some place or another, you're going to find yourself on a Linux command line, and so understanding the basics of the Bash shell and what it can do for you will make your life better in that situation. Okay, good enough. So let's let me share my screen again before I forget. So I put at the end of this session one handout a kind of a table of what is Git and what is not Git, but rather GitHub. So, Git doesn't know about things like team, collaborators, and owners, or organization owners, for instance. Repos are the same in both worlds. Git does not know about orgs, or forks or pulls. I'm sorry, it doesn't know about pull requests. It does know pulls. So when we talk about these operations, this is, we're in the Git column, not the GitHub column for the most part. Like it come in handy sometime to know where you're at with respect to those commands. All right, let's switch gears a little bit and go to something that we're going to spend some time in for a while. So here's my little teaching repo to try to reproduce a project collaboration scenario for you to practice with, basically. So let's start out by pulling that guy down, or I should say cloning that guy down. So first we've got to go back up out of our Learning Git repo to this level, because we're going to clone this tags repo right next to it. So let's type I need a github.com there, don't I? Should do it. Did I misspell it again? Just mistyped. Copy paste is much better. Okay, but here we go. So there it is. Tags. Feel free to follow along with me. So what we have here, do an ADOG, see what we have, is basically just a stupid little web app that does almost nothing, but it has enough functionality, I think, to make it interesting for making changes to. This is the end of the history, so there's not much history there. Here's where master is. And then all this other stuff up here are basically examples of changes you could make. So look back in our repo, it just describes in the README what's going on. I'm going to skip down to where the tasks are here to look at them in context of this ADOG history. So when we start getting into these tasks, you can, for instance, if we want to, here's a real simple one. While I'm talking about that, I'm going to go ahead and build this thing according to these instructions here. I don't know how much of this corresponds with your Python, the way you use Python in your class, but this is a fairly straightforward way to get a Python environment going right here. So I'm going to try that. So this makes a virtual environment. And then I activate it. And then I populate it with the kinds of packages that I need for this project. And using a requirements.txt, which has a list of those packages already, like so. So pip install. Just use that, and that's going to go off and do what it does. And while it's doing that, I'm going to go in another window and continue looking around in this repo. So make it larger. Okay. So for instance, we're here, we want to look at what is in this put the tag input above the tag list. So how is this place different than what's on master? So this is where git diff also comes in handy. So we can go to there with a git checkout. Tag input first, copy paste. And Git is smart enough, at least this version of Git is smart enough to know that you probably want to just track the branch that's already there on the remote side. So it says, okay, I set one up for you here in your repo to track the one that's over here on the remote called origin. And then I also switched to it for you because you did a checkout here. So it created it and then it switched to it. That's what checkout does if it's not there. Turns out that's exactly what we hoped it would do. So if you look at it, now we're down here. Our head is now on that branch where it used to be on master, right? So now we can do things like, we just do git diff, it doesn't show us much, but if we do git diff against master, then we're gonna get some interesting output. So we started, let me clear my screen because I'm confused now. Okay, so that's what git diff shows us. Basically changes that have happened on this branch since it branched off of master. So app.py is what's changed, and this stuff is, you know, taken away, and then we replaced it with this stuff. All that's not going to make much sense unless I can show you the website. So let me go ahead and start this process here. So I've already done this part of the setup. We just now did this. This is going to set up a database. So let me run that part. And then I'll run the part to put some data in the database. And then we should be able to just run the web server or not. Oh, because I don't have a shared, I guess I didn't do that part yet. So let me run this command here. We'll go over all this again, so don't worry if I'm appear to be glossing over all this. Okay, so now my web server is running locally, accepting requests from any interface, any network interface on my box, and listening on port 5555. So we should be able then now to go to there, localhost 5555, and there is our web app. So this is running. Of course, since I switched, this is probably important to know. What branch am I on right now? Well, I've switched branches in another terminal. So let's look and see what branch I'm on here. So that actually applies to the other terminal. So that's something to kind of be aware of as well. Is even if you're working in different terminals, your git state and branch location is with respect to the directory, not the actual terminal you're in. So I'm actually running the version of the website that is on this tag input first branch, not the master branch where I started this on. So, but regardless, what I've done here is move this guy. How have I done this? Oh, yes. So it's kind of hard to see here in the way this is done, but I put some HTML together for this thing to show tags. Let me start it up again, show you what it does. So if I put in a tag, hit enter, shows a tag. I'm just going off names I see on my screen here. So it just adds tags to the database. Now, if I go back to master, I can do a git checkout master, right? Or because I do that so much, I can just do a GCOM. That's another alias I've set up. Now, of course, I have to stop my web server and start it again because it's not going to pick up that change automatically. Okay. Now, if I refresh, watch where the display changes here on the enter a tag versus the tags that are shown. So now I'm back on master. Okay. So that's the kind of the initial state of this website is, you know, it'll behave this way. And if I want to see an example of changes that you know, so what we're doing is we're going to make these changes as a project team. We being your group of 3 to 5, and you can see what those changes, you know, what one solution could be for those changes by looking at the branches of those on which those changes live. Some of them are more huge changes than others. This one you probably won't get to, honestly. That's a lot of files and a lot of changes. But I put it out there in case you get your project team is doing great and wants to try something more challenging. So, for instance, this one that we looked at here, which is also reflected in this round 1 task, is an example of a change you could make. So for instance, you know, the website, as the tag list grows, the input moves further and further down, which is not great. So you sort of have to chase the input box as you add more tags. So it made more sense to put the input box up ahead of the tag list. So that's an example of one change you might make to this project. And you can see, if you check out that branch, let's see, where's that checkout? Let's look at that diff again. Versus master, get diff master. You know, so the HTML that had the tags was there. So that's the list of tags, and the HTML that had the form input was afterwards. So all that this change did really was switch around the form input to be first, and the tags to show up later. Right. So that's one implementation. Probably not much more to it than that. So the idea is hopefully that you would be more doing project collaboration and working out those kinds of workflows than you would be actually focusing on the Python. See how that goes. So in fact, if you want to just go ahead and take these changes and put them into your branch, then that would be totally fine. You know, you wouldn't be plagiarizing. That's okay. You feel great about that. You'll still get plenty of interest as far as merge conflicts and, you know, order of changes and integrations and making your app continue working and all that kind of stuff. So what time is it now? Let's try to run one, like just a 2-person project, and make one change just to see how this would go. Can I have a volunteer?
I'll give it a shot.
All right, Jared, here we go. So here's what we'll do. We'll just follow through this. Instructions over here. Now to start with it, let's see if I've said this here. Okay, so to start with, so Jared, you'll be our project manager. So congratulations, you've been promoted. You will fork my repo on GitHub. So you'll actually go to github.com and do a fork, and then our project team will work from your fork.
Okay.
So you'll need to
forking it now.
Sure. So you'll need to add me to your fork as a collaborator. So
Yeah, I just sent the invite.
okay. Which actually I need to do it here. Hold on. There it is. Okay, so I will accept the invite. Okay. Let me go here and pull it down. So I'm going to move my tags directory to like tags.original or something. Get it out of the way. Then I'm going to do a git clone of the fork repo under Jared's account. Okay, fantastic. So now, Jared, you would of course go ahead and get these things running in your environment, and then we would basically choose tasks to start in on. So I put some hints on how to look at these basic or these various branches here. Probably these round one tasks. Knowing how our session went on Tuesday, I would suggest that we do view template last because everything else depends on it, as it turns out. How about we tackle style sheet and tag input first? Would you want to give me one or the other of those? So there's this.
Yeah, let's go with let's do style sheet.
Okay.
And I'm working through the setup still.
Okay, cool. So I'll demonstrate starting on the style sheet change. That's how I would approach it. Okay, so here we are in the tags repo. I'm just going to cheat and copy over my VENV from the other one, since I've got it all done. Should just work. Then I'll go in there and, oops. Did I do the right thing? Where did it go? Tag original. Well, that's interesting. Okay, there it is. I don't know what happened there. Okay, so then activate. There I am. I need to load my schema. Oh, you know what happened is I blew away that slash on the end of my previous command. Put me in a really strange state. So I copied the contents of what was in VENV instead of VENV itself. So, which I'm sure no one else would ever do, but that's what happened to me. So let me try this again. I'm going to remove my tags directory and reclone it. So here we go. CD in there. Try the thing that was supposed to save me time again. And I also notice I'm still in this, so I'm going to get out of it and back in just to make sure I'm in a a good environment state. Okay, that looks more kind of normal. Yeah, there it is. Okay, so now I should be able to run bin. Or maybe not. Yeah. Python bin. Here we go. Python bin seed. And then I can do my bin run Flask web server. Oops. But it's still running over here. So you might have seen this already somewhere. Address already in use. That just means you're already running something else on the same port. So for what that's worth. Okay. So there's my web server running. It's working. Okay, and you wanted me to do the style sheet one? Is that right, Jared?
Yep.
Okay, so style sheet. All right, so I'm going to cheat and look at the solution. And to do that, I have to find the corresponding, there it is, the corresponding branch from origin.
And Chris, real quick, I think I've gone through all of the install and setup correctly, but whenever, and my server is running, but whenever I'm trying to access the page, it's just kind of hung up and not going anywhere.
Okay, you want to share your screen? I'll stop my share. Are you able to share your screen, Jared? Okay. So can you type anything into the enter tag?
Yeah, so actually, I don't know what happened whenever I started sharing the screen, but it just like popped up as soon as I shared it. So.
Huh. Interesting. See if you can throw a tag. See if it's going to respond to you. Okay. Awesome. Awesome. Yeah, I don't know what was going on there.
Yeah, I could try to. Yeah, it looks like it's working okay now.
There may be sometimes it'll. I've noticed my Mac asking me if I want to let this thing connect. So sometimes there's a dialog that pops up that may or may not be obvious to allow permission.
Cool.
So maybe that was going on. All right. So I'll share mine back again. Oh, you gotta stop sharing yours first. It looks like.
Yep. Just did.
Awesome. Okay, so let's look at style sheet. So we can't, we have to go there first. So we have to do the git checkout, style sheet, get that message that a branch has been created for it. And there we are on this branch now. So now we can do a git diff master. Now clear the screen so we can see what's going on. Okay. So looks like I can just go ahead and take this change as it is. Okay, so since I'm local, how are we going to do this workflow is the next question, right? We've got the master branch. I think probably what we'll want to do is ultimately get all of our changes collected onto the master branch. So if I'm working on Stylesheet and Jarrett is working on the tag input first, for instance, then the first one of us to go is going to have it easy because there's no changes to contend with. So if I hurry, I can get ahead of Jarrett. Not that I would ever do this, of course, but I can just go ahead and git merge that Stylesheet branch onto master. Boom, my change is done. And I quickly push. Gosh, now I've got to remember my password. I don't even know my password. Let's see. All right, I'm going to cheat again.
This is where I'm going to catch you.
Yeah, doggone it. All right, so I'm going to basically change my protocol from HTTPS to SSH because I know I have SSH keys already up on GitHub, which should let me authenticate with my SSH keys. And it's easier than looking up my password too. But first I have to remove the remote that I have here. And notice my remote is named origin. That's the default name Git gives when you pull something down without telling Git what to name it. So I'm going to take it away, and then I'm going to add another one. So remote add, and I'll call it origin. I'm fine with that. But instead of using this protocol, I'm going to use SSH, which looks more like this. And instead of having a slash here, it has a colon, and then everything else after that's the same. Right? And so then I can do like git ls remote just to make sure. Yeah, so if I get something back, then that means I'm good. I've successfully changed my remote to something I've changed my remote in a way Git understands. All right, now can I still push, or is Jarrett got ahead of me? I guess I got to set the master. So I could just do git origin master explicitly. Okay, I guess I did get ahead, Jarrett. So let's look and see what happened. Okay, so here's master. So did I actually do anything? I don't think I did anything. Yes, I did. Yeah, this is where we used to be. So I did get my change in here. I did move origin master up, basically caught origin master up on the other side, up to where my change was. And so now if Jarrett tries to do some stuff, he's gonna have to do some merging. Right?
So I should check out like tag input first and then try to push that up.
Yeah, you can check it out and just go use it directly as your change if you want.
Okay.
Yeah, see what happens. Actually, you want to share your screen? That'd be interesting to look at.
Sure. Okay. So I just stopped the server.
Okay.
So I should check out.
So here's a question. Can you see my changes?
Should I try to pull it down again?
Yeah.
So
Yeah.
is that just get pulled?
I just try git pull, see how that does.
And then that would like.
Yeah.
Oops. Yeah, so
There we are.
here. So should I try to reload or run the server again?
Yeah. Yeah, just because I forgot to do that, and which is bad on me. Did not check my changes, check that my changes work before I push them. Okay. Cool. So
Is there-
now
is
let's actually see. Let's see if it is cool. Let's go to the go right click on the image and do inspect element. Okay. So there's the image. Go to sources there on your right next to network. Yeah. Okay. Yeah. So we did pull down a style.css, which was not there in the initial. So if you click on style.css there on the left, yeah. So that is our style sheet, the whole wonderful contents of our style. But so it does look like you got there. So cool.
All right. So I need to check out another branch.
Mm-hmm.
So tag input first.
Right.
Or has that already been integrated?
It hasn't been integrated. None of these branches have been integrated to master.
Okay. Because so I was just looking at this. So does this not mean that the tag input?
So that is a database. That's not checked into Git.
Okay.
So actually, let's pause there. Go to your command line. That's a good point. Why does that database not show up? Because right here, type so back up. So do cat space. This is another Git feature. .git .git ignore. Cat .git ignore. There you go.
Cat .git ignore.
Mm-hmm. Are you guys familiar with that at all? Covered ignore?
Yeah, we have.
Okay, so notice that it says star.sqlite 3. So if you do an ls space db, I think is where you look. Okay, enter. Yeah, so our load schema and seed are actually working with a SQLite database called development.sqlite 3. But because we've said to ignore that in our git ignore, it doesn't show up in any of our git status or git add commands. So
cool.
So there you go.
So I'll do just tag input first.
Right.
And then a merge with master.
Mm-hmm. Now we haven't covered this, so it's a little unfair to do this, but let's go ahead. So how do you do a merge?
I'm guessing you do git merge, and then it takes the current branch that you're on and merges it with whatever branch you input as an argument.
Yes, and the key is what we're merging from and what we're merging to. So if you say git merge master, which is a good thing to say here. Okay. Okay, so what happened?
The stuff you've already changed conflicts with what I'm trying to change.
Right. And the other question is, are we merging from master or to master?
I guess from master.
Correct. Yeah, the merge is with respect to where you are now. So when I say git merge master, what I'm saying is merge from master to wherever I'm sitting now.
Mhm.
So we're coming out from master, basically, pulling the changes out from the master branch onto our current branch. And yeah, now we've got conflicts. So do a git status. Okay, so Git kind of knows that you're in the middle of a merge, right? You can see that it says you have unmerged paths. Here's how to bail out and not, just stop by doing -- abort, and kind of pretends you never started it. But if you continue, you can go ahead and make the change. Make whatever changes should be made to the file in red, and resolve those changes, and then you can from there do a commit of the changed content.
Okay. So should I use the argument listed there, like git add and with @py?
Well, it's to mark resolution. So yeah, once you've made the changes, then you would do that.
Okay, I see.
Yeah.
And how is it that you can see like the conflicts again?
You just edit the file. Yeah, it actually munges up your file with, as you open it, you can see that it has shown you where the conflicts are. Go on, yeah.
Okay.
So notice at the top, there's annotations at the top and bottom.
Mhm.
So, before the equal signs is the what you've done on head. And then after the equal sign is what is coming in.
I see.
It's not what you've done on head, it's what is on head. You may or may not have changed it, but it's, where things are at on head versus what is trying to be applied from your source that you're merging from.
Okay. So we should, I guess, accept the incoming change.
Well, let's see
Finish
what's.
what we do.
So you know what I did, right? What did I do? What was my change?
Added the style sheet.
Right. So then in yours, what's your change? What kind of what are you trying to accomplish?
Yeah, so I've got my tag inputs first. So finding that body. I got maybe just more descriptive with the tags that we're using.
Okay.
Or
So
that's like H1 and the divs.
yeah, so we want to keep the href style stuff, right? That looks good in the second part, but we're trying to move the form HTML up ahead also. So there's basically part of the change is in the first part and part of the change is in the second part.
Right. Okay. So then, is there an easy way to? I guess this one's kind of weird just because it's in HTML. And I'm just used to like seeing it in the stacked version of it.
Yeah.
Is there a way? Will one of these commands like spit me out into like another window where I can kind of move them around more easily, or do I just have to kind of figure it out in line in here?
That kind of depends on your editor. I mean, what you're seeing is just what Git did to the text of your file.
Mm-hmm.
Sometimes editors will let you like diff side by side, and even that what you're seeing there with accept current or accept both or compare or live share set, that all is your editor. That's not Git.
Okay.
The Git part is just lines 21 through 25.
Right.
That's what it did. So if you can figure out how to tease out what you want to keep, you could just edit those directly and then just delete everything else.
I see.
What happens if you hit compare changes? What does that do?
That's what I was hoping for. Okay.
Okay, that's pretty cool. So although you're not getting a whole lot out of that.
Yeah,
because
it's still the same line at the end.
yeah.
So big line.
But it does, do you have any line wrapping options on your editor?
I forget what's anybody from the class remember that offhand?
I think if you open up your settings.json GUI, so if you just hit Command Shift P, and then type in settings, and then open up the GUI, the UI preferences, open settings UI, and then middle, and then try typing in the search bar like wrap, something like that. And there you go, editor word wrap on, and then 80. Looks like you have it on. It may just not work in the split windows.
Yeah, it could just be there's no places for it to break on.
Okay.
So yeah, maybe go back to where we were before. There we go. And so all you really need to do, I think, is if you take the line 24 and you flip tags and form around, where it says tags HTML and form HTML, that's the essential
Okay.
difference
Yeah.
that you want to apply.
So just
Yeah. Right. And then you would just get rid of everything else. Get rid of, lines 21 through 23, and then get rid of line 25.
so if I accept incoming change now, will that keep the changes I just made, or will it revert to what it originally had?
I think if you hit incoming change, I think it would keep it.
Okay.
Let's see what
I guess
happens.
we can just watch it. Yeah.
Okay. I think I like that. I think that looks good.
Okay.
So yeah, you still got your style CSS change in there. You've made the change that characterizes what's on your branch. So yeah, should be ready.
Okay.
So all right. So then one thing I would do now is do a git diff, just to see what we're going to be working with. Okay. I think I like that.
Okay. Let's see if this. So try to merge again.
Well, you're in the middle of a merge, so now you would do a git add to
Okay.
result to mark the resolution. Yeah, it's as they put it. Oh yeah, GA space dot or star. Yeah.
Sorry, I'm a little laggy on some of the responses.
There we go. Okay, and then GS, yeah. So now everything looks like it's teed up. So it says, okay, you're still merging. So now to finish the merge, it's just a matter of doing a commit.
Okay.
And actually, yeah, it mentions that there. Use git commit to conclude merge.
So
Cool. And then maybe try running your have we tried it since you've done a git pull? I forget if we run your app.
I see.
Git pull.
I guess I have to git pull again.
Well, no, because we haven't.
Oh yeah, because we made these changes.
Yeah, we're just changing your local resolution. So
I should run the server again and look and see how it looks first.
Yeah.
I forget is that?
Yeah, there you go. Auto then tab. There you go. Perfect. So now while Jared's been doing this, in a real project, other people would also have been working, right? So there could be other changes that have come up onto master. So Git supports collaboration, but it doesn't do it all for you. You have to actually still communicate if you're going to work efficiently. because otherwise poor Jared's gonna, get this change fixed, and then he's gonna try to push again. He's gonna fail because there's other changes. He's gonna have to pull again. And, if it's a fast moving project, it could be really frustrating to try to get your changes up in the master. So very often other communication is required beyond just, talking through Git pushes and pulls. So have we got it?
And so I can just push this up now.
Have you tested your app?
I did. So it
Awesome.
swaps
Awesome.
the form here.
Okay. Yeah. Sounds good.
And I guess I could actually check the. Yes, it's got the style application still.
Sweet. Yep. I like it.
All right.
Much better than it was before. Okay.
Yep.
So, yes, give it a push.
Sorry, it's lagging on me a little bit. There we go.
Now, actually, let's think about this a minute, because you're not actually on master, are you?
I'm not.
So if you push, you're going to just push up your branch. So we've merged from master, but we haven't merged to master yet. We've
Right.
integrated the changes, but we haven't delivered them, if that makes sense.
Yeah. So I should check out master.
Yeah. Okay.
And then so did I merge from here also? Or merge at here, like from the branch I was just on?
Correct. Exactly right. Okay. And now, because we're all local right now, right? So no changes have flowed onto master because you haven't done a git pull, right? So you're good. You're all good. So if nothing has come in on the remote side, you should be able to push with no issues.
I have a question, Chris.
Sure.
If something had come in on the remote side after he did his merge locally, would he do a git pull again and then do a merge or a git push?
Right. So he could do that. So if that had been the case, it would either just update, or more likely you get a collision on master, and then you would say to yourself, shoot, I should have git pulled before I merged back into master, because now I've got more changes to integrate, right? And that's where you kind of get in that cycle where you try to get master quiet enough so you could merge to it and push up. And that, could require communication with your team to say, please give me a chance. But that's the, the discipline of the collaboration through Git branching and merging and pushing. Good question. So I'm going to stop here. There's clearly much more we could cover, but I hope that gave you kind of a sense of what what project collaboration would look like in this project. And I think there should be enough here for you to, if you want to go ahead in the interim and you can pull down this repo even before you get organized into your project teams, and take a look and make sure your environment goes the way it should. I guess the next step to set up for Tuesday would be for Tom to set up project teams, and you could either self-organize a project manager or have Tom choose one, whatever you decide. But in the meantime, you could still go ahead and just play around with this repo and look at things on those branches. Let's see, anything else that might help with that? Yeah, I think there's enough to cover in here. So being familiar with what those tasks are, I think will help to make the project practice go smoother next Tuesday, if you get a chance to do that. Any other questions, comments before we call it a wrap?